In this video, we are going to be discussing how to factor trinomials where the leading coefficient is 1. There are 3 steps we want to try to follow when we are factoring trinomials. The first is that we want to ensure the polynomial or the trinomial is in standard form, which means that the x squared term comes first, the bx term or the x term comes second, and the constant is at the end. The second thing we always want to do is check for a GCF. Okay, so can we see a GCF? If we can, then we are going to factor a GCF out first. And then the last piece is to factor, which means you're asking yourself what multiplies to C and adds to the B term. Okay. When you factor a trinomial, you're going to want to set up what I call your frame, and your frame is a set of parentheses like this. So to begin, we want to remember that factoring is the reverse of multiplying 2 binomials together. So in this case, we have our frame. If you were to multiply 2 binomials together, in order to get x squared as your first term, the first 2 values in these parentheses would have to be x. Okay, that's because when we multiply it out, x times x gives us x squared. Next, we're going to answer a question, what multiplies to the 15, multiplies to the C term, and adds to the B term. So you're asking yourself, and a lot of times we like to use this diamond shape, what multiplies to 15 and adds to 8. So 2 things that multiply to 15 and add to 8. If you're not sure, then write down your factors of 15. Things that multiply to 15 are 1 and 15, 2 doesn't go into 15, 3 and 5, 4 doesn't go into 15, and then you're back at 5. So I wrote out all my factors. These are the factors that will add to 8. So it's x plus 3 and x plus 5. It doesn't matter if you would have put the plus 5 on the left and the plus 3 on the right. It will still give you the same answer. This is your final answer. If you wanted to check your work, you could multiply this back out and say, okay, I get x squared plus 5x plus 3x plus 15, and then combine like terms, x squared plus 8x plus 15. It does in fact work. That is correct. Okay, in the next question, again, I set up my frame, which is my sets of parentheses. Because I have a 1x squared here, there's going to be an x and another x for your first terms in the parentheses. Then we're asking ourselves, what multiplies to 36 and adds to negative 13? So multiplies to 36, adds to negative 13. If you're not sure, 36 has a lot of factors, so let's write out our factors. 1 times 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't go in, 6 and 6. When you're looking for something to multiply to a positive and add to a negative, I want you to think about the fact that you can only get a positive answer if you are multiplying 2 positive values or 2 negative values. So we want to look to see, since we know that if we're multiplying to a positive and adding to a negative, both of these signs are going to have to be negative. The only way we're going to multiply to a positive 36 and add to negative 13 is if we multiply 2 negative values. So we want to look here to see which of these 2 values would total to 13, and that's 9 and 4. So x minus 4 and x minus 9. And again, those could be x minus 9 and x minus 4. You could switch the order, it would be the same. Okay, let's do example D. So I'm going to set up my frame. I'm in descending order here. I'm going to ask myself what multiplies to negative 20 and adds to negative 1. The only way we're going to multiply the first two terms to x squared, each one has to be an x in our parentheses. But the only way we're going to multiply to a negative 20 is if one of our signs is positive and one of our signs is negative. So when I list my factors of 20, 1 and 20, 2 and 10, 3 doesn't go in, 4 and 5, I want to look for two numbers that would multiply to negative 20 and add to negative 1, which means I actually want these values here to subtract to 1. So 1 and 20 is never going to give me a negative 1, right? If I add 20 and 1, I would get 21. If I subtract 20 and 1, I would get 19. So that's not going to work. 2 and 10 also will not work, so it has to be 4 and 5. In order to get a negative 1 as my B term, I have to have more negatives than I have positives. So the 5 should be negative and the 4 should be positive. And again, you can check your work by multiplying that back out. In this example, we don't see a B term. This would be the same as if we wrote 0 as the coefficient on the x term. Okay, so we can still ask ourselves the same question. We're going to set up our frame and say what multiplies to negative 81 and adds to 0. If we start with our x's here, the only way we're going to multiply to a negative is if we have one positive and one negative. And the only way we're going to add to 0 is if those numbers match, right? The only things that add to 0 would be like 9 plus negative 9, 4 plus negative 4, 3 plus negative 3. So if we're thinking about factors of 81, our only options are 1 and 81, 3 goes into 81 27 times, 9 and 9. So we want the numbers to match. It would have to be plus 9 and minus 9. Okay, let's do one more example. If I had something like x squared plus 10x minus 24. I'm going to set up my frame. I have an x here and an x here. The only way I'm going to multiply to a negative is if I have one positive value and one negative value. So my factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. And I want them to give me a positive 10, which means that if one's positive and one's negative, I really want to think about these values subtracting to 10. So 4 and 6 would add to 10, but would subtract to 2. 8 and 3 would add to 11 and subtract to 5. It has to be 2 and 12. So if I want more positives, if the 10 is positive, I want to have more positives than I have negatives. So I'm going to put the 12 with the positive symbol and the 2 with the negative symbol. This is a tricky one because so many people will try to say that it's x plus 4 and x plus 6, but that wouldn't multiply to a negative 24 with your n terms. Okay, that's it for now. If you need help remembering how to multiply them out to check your work, you can see a video on that in the Unit 7A polynomial section.